Welcome to everyone from your winter break. Hopefully everyone had a productive and restful winter break and now back to the spring semester to do organic chemistry. This course is Organic Mechanisms and Structure. If you are taking this course as a graduate student, the course number is CHEM513. If you are taking it as an advanced undergraduate student, the course number is CHEM489. Let's do some introductions. So my name is Alan Headley. I am the instructor of this course. Hopefully everyone got my introductory email that I sent out earlier. I am a professor of chemistry here at the university, Texas A&M University Commerce, and this is my email address right here. And that's my preferred mode of communication. I mention that because here's my phone number, but a more reliable method to communicate with me will be through the email. Let us look a little more in detail at the course before we actually get started. So in this course, the assumption is made that everyone has a thorough understanding of sophomore organic chemistry. That's your undergraduate sophomore organic chemistry. And in this course, you are now ready to carry out a much deeper analysis of reaction mechanisms and the factors that are used to determine these reaction mechanisms. I'm sure you may have wondered while taking your sophomore undergraduate chemistry, when you write a mechanism and one of the intermediates is a carbocation, you may have wondered, why is it a carbocation and not another type intermediate? In this course, we will use experimental factors to determine what type intermediates exist for a reaction. In this course, we will also study stereochemistry or revisit stereochemistry, but in a more in-depth manner compared to what's done in sophomore organic. We'll also look at the conformations of molecules. So again, remember, conformations here are isomers that differ only in rotation about a single bond, whereas stereochemistry here deals with the orientation in three-dimensional space of the atoms in a molecule. But we'll cover those in more details. We will also cover the formation and reactivity of different type intermediates. The intermediates that we'll be concentrating on in this course include carbocations. We know what those are. Those are carbons that have positive charge. We'll also look at carboanions. Those are carbons with a negative charge, with an unshared pair of electrons. We'll also look at radicals. Radicals contain carbon with an odd electron. Another type intermediate that we'll look at is the carbenes. Very reactive carbenes. They are neutral species, neutral carbon, which are divalent. We'll also look at electron deficient species. And in particular, or in specific, we'll look at electron deficient nitrogen and electron deficient oxygen. These are all intermediates that are formed as a reaction proceeds from reactants to products. In addition, we will look at experimental methods that are used to deduce reaction mechanisms. As expected, as chemists and scientists, we rely heavily on experimental results and observations to determine conclusions. So we'll use these experimental methods to determine what type intermediates exist for a reaction mechanism. One that we look at is called the kinetic isotope effects. There are two types, the primary and secondary. As you may recall, an isotope is isotopes are atoms that have the same number of electrons and protons, but different number of neutrons. But we'll use them as part of experimental methods to help us understand a reaction mechanism. We'll also look at linear free energy relationships. This is also known as the Hammett equation. So we'll utilize this concept to assist us in determining a reaction mechanism. The reactions that we will use, or the reactions that we will be analyzing using the methods described earlier, will be the acid-base reaction. We'll also look at substitution reactions, addition reactions, elimination reactions, and pericyclic reactions. So once again, these are the reactions that we have seen before in our undergraduate sophomore organic chemistry, but now we'll just look at them in much more details to determine and analyze the reaction mechanism. So course learning objectives. So my objective for students is that you should be able to read and understand recently published manuscripts that relate to the topics covered in this course. So as you can imagine, as advanced students, you should be aware of what's published in the literature, and you should be able to read recently published manuscripts that relate to these topics and understand them, essentially. Some of the exam questions that you will get throughout this course are really made from recently published manuscripts. But I'll say more about that throughout the course. In addition, it's my hope that you will develop and improve on your critical thinking abilities. So your critical thinking and analytical thinking about various research questions. Some of you are involved in research, and to carefully design your experiments, you will have to be critical and analytical thinkers. Some of you are teachers, so to be able to fully communicate these concepts, you have to be critically and analytical about how you communicate your concepts to students. So at the end of the course, it's my hope that students would have a much better problem solving and improved scientific skills. So at the end, hopefully, will be an improved scientist. Grading. So the grades are based on the following. There are 3 midterm exams. Those are, I call them midterm because they are exams given within the semester. And the value of these 3 exams are 60% of your final grade. In other words, each midterm exam is worth 20% of your final grade. There's a written research project that I'll assign each student, and that's 20% of your grade. I'll give you more details on that project towards the middle of the semester. And there is a final exam that's worth 30% of your final grade. So this is how your final grade in this course will be computed. Exam schedule. So we'll have our first exam the week of February 14th, the second in March, the third in April, and the final in May. This is given in the university schedule, but I'll say more about that. The exact time and date for these exams will be determined based on a survey that I'll give you students, and so we'll just set a time and date based on your schedule. One thing I should point out though is that the time that I will communicate to students will be Texas time, which really will be written as US Canada Central Time. So if you are in a foreign country or a different parts of the US, make sure that you correlate your time to Central Time. In terms of the actual grades, so the average of a class like this is typically around 77, 78. If that is the case, and we hope that will be the case, the normal cutoffs will apply, such as 90 to 100 A, 80 and above B, 70 and above C, and so on. If the class average is lower than our 77, I'll adjust these cutoffs here to reflect that lower average. But I'm hoping that we won't have to do that, because we'll all get averages on these exams that are higher than 77. I should point out here that since this is an online course, we will be using the Zoom tool in D2L, or I'll give you more information about that, to monitor and ensure the security of exams. So you'll have to get your computer, turn on the camera, and keep it on for the duration of the exam. So a little more details in terms of the structure of the course. So we will not, notice here, not have scheduled online lectures. In other words, we will not meet at a specific time for online lectures. But I will share with each student the YouTube link for lecture videos. Okay, so I will share the link for lecture videos, and it is your responsibility to watch these lecture videos in a timely manner to match the topics outlined in the textbook or topics outlined in the course syllabus, and of course study along in your textbook. So once again, just to make sure we get this, so the YouTube lecture videos will be shared with you, links will be shared with you. It's your responsibility to watch these and study along in your textbooks. They are typically around 30 to 45 minutes in length. So again, secure a time based on your schedule when you can watch these videos and study along with them. The first video on lecture number 1 will be posted shortly on YouTube, and I will email the link to you. By the way, I do have a YouTube channel, Alan Headley. You can subscribe to it and you will see when they are actually posted. I also have on that YouTube channel lecture videos for my undergraduate sophomore organic. So in case you need added resource or to refresh your memory on different topics, you can view those also. The PowerPoints for each lecture will be available if you need it. So to send me a request, if I get a lot of requests, I will more than likely post them in D2L or some common platform that you can view them. The exams. So in terms of the exams, at the scheduled date and time, I will email the exam to you. Notice I'll email that exam as an attachment. Notice again, the time that it will be emailed will be Central Time. Students are required to provide written responses to the questions. When you are done, you will have to scan your responses as one file. So if you have 3, 4, 5 sheets of paper, please scan them as one file and upload to D2L. I'll tell you exactly where to upload your responses for grading. Once again, the exams will be timed. So if it's a 2-hour exam or a 1-hour exam, it will be timed and you will have to upload your responses by that specific time. The detail about the research project, as I mentioned earlier, will be given later in the semester. Just to give you an idea of what I have done in previous years is to have students use a particular molecular modeling software called Spartan to come up with a research project, but I'm not sure we can do that online because it's a software that's on campus. But I will look into that and get more information to you. Course requirements. As expected, you need a basic knowledge of the internet. Of course, we all do in these times. But equally important to interface with D2L Brightspace, which is our learning management system for the university here, Texas A&M University Commerce. So in other words, you need to be able to get to D2L. You can send me an email if you are having problems getting to it, but the best way to get to it is to log on to the main page of the university, www.tamuc.edu. Look at the bottom left, you'll see My Leo. Click on that and you'll have to log in based on the information that you get when you register. In addition, students must have the ability to scan written work and convert it to PDF file for upload. So there are many free applications that are out there. One that students have found very helpful and useful is one called CHEM Scanner. So just go to your app store. If you don't already have it on your phone, go to your app store, download it. It's just a matter of taking pictures of each page and convert it to a PDF and just email it to yourself and upload it as a file to the D2L. Your textbook is shown here. Its structure and mechanism in organic chemistry by Felix Carroll. The second edition. If you have the first edition, that should be okay, but the second edition has a little more detail and a little more information compared to the first edition. So you can get that online. I think it's available through Amazon, and so that will be needed. I wouldn't even say helpful, but needed as you work through this course. Just to summarize, so the YouTube links will be shared with each student, and so you can watch the video in a timely manner. Each exam will be administered through D2L. They'll be emailed to you, but you'll have to upload it to D2L, which is, as I mentioned, the learning management system of the university. Grades, running grade averages. So each time you take an exam, your grade will be posted in D2L. Not really the letter grade, but the percentage will be posted in D2L. And notice here I'm saying that the running grades will be posted, which means that after the second exam, the average will be computed, and you'll see the average for both exams in D2L. As you take the third exam, it will be computed, etc. And in addition to grades being posted in D2L, important information and communication will be emailed to students or posted under the announcement tab of D2L. So again, you may want to have a alert in your phones or your computer, so that whenever there is an announcement posted in D2L, you know it's posted and you can go and read it. I'll also email to students different updates, and that will come through your university email address. So again, make sure you check your emails frequently. General advice. It's best to develop a schedule. So again, I know an online course, it requires a lot of discipline, because you will have to select a schedule for working organic chemistry problems and studying advanced organic chemistry. It's not like face-to-face where you are required to meet for 50 minutes every Monday, Wednesday and Friday, for example, and we talk organic chemistry. But here you'll have to develop the discipline to set aside an equivalent amount of time each week, each day, to study organic chemistry here. Read ahead. So when you get your textbooks, read ahead of the material that's being posted in the lecture videos. Practice lots of problems. There's some problems at the back of each chapter in the book. Try to work those. read published manuscripts that are related to the lecture material. So we are fortunate in these days with the internet that you can go on to Google or Google Scholar and type in, for example, isotope effects or whatever we're covering, and you will see literature that are published. You can download it and read it. From time to time, whenever I find a published material that relates to what we are covering, I will email that manuscript to you so you can read it and understand it. And as I mentioned earlier, some exam questions are taken from these manuscripts. So make sure you are up to date with the research that's being discussed in the course. Ensure that you understand the concepts. Concepts are very important for each of the problems at the back of the chapter or in the published manuscript that you're reading. Utilize the Zoom virtual office hour. I'll say more about that in an email. But there is a feature in D2L on the Zoom that you can log into, and you can interact with me or interface with me through a whiteboard, and we can discuss any problems that you may have or any questions you may have relating to a problem. It's a feature that you can draw a molecule on your side. I'll see it, and I can draw a molecule on my side, and you will be able to see it. So once again, the virtual office hour will run the same time as shown in the syllabus that I posted in D2L earlier. But you can also email me, and hopefully we can set up a meeting if we have enough students to do that. I wouldn't want to set up a Zoom for every individual students, because that would take a lot of time. But hopefully if we get enough students going, we can schedule virtual office hours outside of the office hours that's in the syllabus. Also nurture your ability, your critical thinking ability and skills. So continually asking questions, continually thinking through and solving problems, and that is a way to develop your scientific skills, which is the goal of us being here at the higher education level, is to really become better scientists. So once again, have a great semester, and I will be sharing more information with you starting this weekend. So look out for that. Hopefully I can share the first video before the weekend is out, but if not, first thing in the week. So be on the lookout for your first lecture video. Okay?